Yeah, the verge is not going to break our contracts. That's good, right? So I work for OpenZeppelin, and at OpenZeppelin we provide all kinds of services to the community that obviously includes the open source smart contract libraries, but also audits and so on. And we do that because we want to provide a good context, a good ground for developers maybe like you to build the next $1 trillion economy that is going to be powered by smart contracts. And so in doing so, we want to understand what's the environment you'll be working with, how the EVM works, how the blockchain works, and share that knowledge with you through these talks and also through the best practices that we apply to our contracts. And yeah, just a few days, maybe weeks ago, I don't remember, we released the last version of the smart contract library, the version 5.1, that's been in the making for quite a while. And to me personally, it's a big milestone because it's the first time that we put knowledge of upcoming blockchain change like the verge into the design of the contract. We adopt a proactive approach so that the contract you deploy today may be more efficient in a few months. So what is the verge and how is it going to affect dev? So I was told to not talk of the merge too much, but to rather mention the transition to a more stateless Ethereum with stateless clients. The verge being one of the approaches for that transition. And what the verge does and how it can achieve better statelessness, a stateless client, is by changing the storage layout to be more friendly to ZK proving. So right now what we have on Ethereum is a storage layout where we have a Patricia Merkle tree that is divided in two sections. And the top section is basically the entire world of accounts. And under accounts, some accounts don't have storage, and that's done, but some accounts do have storage. And then you have to go further down into the account storage tree. And that's how it works. And when you want to prove some storage, you have to prove a Merkle proof that goes all the way from the bottom to the top. And that's kind of long, that's kind of expensive, that's impractical if you want to build a stateless client. So what the Verge does is propose to change this storage layout to use a Verkle tree that contains all the data of all the accounts in a different pattern. And basically, there are still somehow two sections. There is a main tree that are the first 32 bytes of this Pedersen hash that is computed using the address of the account and the offset being like the position in the storage that we already have. And then that gives you an extension, and an extension contains 256 values. And then you use the last byte of your position, of your offset, to know where you're in the extension. That means that an extension is owned by a single account, but then all these extensions of all these accounts are in the same Verkle tree. And this is a radically different vision from the previous slide, because in the previous slide, all slots were identical. Slot 1 and slot 20 were basically the same object, and warming one up was required when you wanted to read or write to it, and the same was true for the other slot. And all slots were identical in the sense that you would have to warm them up individually. But with the Verge, what you're warming up, and by warming up in the case of the Verge, we don't really, what we mean is put in the proof, sorry, in the commitment. I don't remember the name, it will come back. But what we do is we put this complete extension and we prove it. And this completely changed the paradigm, because if you want to access two different slots, if they are in the same extension, you only pay once. So it's way more efficient to access storage that is close to one another, which was not the case before the Verge, which is not the case today. And so this is a rough timeline. We go from Devcon that we passed to Pectra that is coming soonish with a lot of great features. You may have heard about it during Devcon, to hopefully the Verge. This is changing. There may be Fusaka before. I'm sorry for that. But yeah, I'm really looking forward to this, as I hope many of you also are. And this will impact our contract, as we see. It will impact them in the sense that the gas cost will be measured differently, and that has an impact. So that's why what I want to dive into today. And disclaimer, this is work in progress. The Verge is not definitely final. And those are the best numbers I could come up with the help of Guillaume from the guest team, from the EF. But those are possibly not the final number, but it's still a good idea. So let's dive into this first graph. There are going to be a few of these, so please make sure we all understand what the color means. Here we're representing the gas prices of frequently done operation on tokens such as ERC20, 725, and 1155. And we have two types of operation. There are the simple transfers that are in blue, and there are the transfer from, so transferring someone else's token using a permission, that are in green. And in both cases, you have like a light blue, a light green, and a dark blue, a dark green. The lighter colors are the costs that apply today. The darker colors are the costs that apply after the verge. And this color scheme, we will keep it. Like lighter is now, darker is after the verge. And what we see here is that basically for all classical transfer operation on tokens, it's going to be more expensive. That's the bottom line. But not by a lot. So it will still continue to work unless you're crazy enough to hard-code gas prices somewhere in Europe, but like it could continue to work. But like ERC 721 is going to be affected a lot. The reason it's more affected than the other is like when you do a transfer from or a transfer in ERC 721, you are checking two types of approval because you can approve one token and you can approve an operator. And those two checks are two slots that are being warmed up and they are not in the same location, so there are two extensions. So the price, the over cost of farming an extension is significantly more visible in the case of ERC 721. And then let's look at other contracts that are quite interesting. There are the governance contracts. I love governance. And here we are looking at Open Zeppelin contracts in blue and Compound Governor Bravo in green. And we're looking at the different operations that are done in the life cycle of a governor proposal, which is you propose, you cast a vote, you queue, and then you execute. Here in the execute, we execute something small so that the actual cost of the execution is hidden. What we only look is the cost of the governor part. One thing that is quite interesting that we see is that for Governor Open Zeppelin, the price doesn't change that radically. The execute is a bit more expensive, but otherwise it stays pretty similar. And there is a good reason for that, is that in our Governor, we don't use storage that much. We try to reduce it to a minimum. On the other hand, Compound uses a lot of storage because when you propose, you store the proposal to the chain, and then you refer to that proposal stored on chain through its identifier. And what's good with Compound Bravo is that the proposal is stored in a structure that is very sequential. So it turns out to be very efficient in the context of the verge because like most of the proposal will be in the same extension. So you are actually saving a lot of cost by warming up the entire extension rather than warming up many, many slots. And that's why the verge is actually reducing the cost of the execution on Compound, at least in the proposed part. So the idea that the verge is going to make all contracts more expensive is wrong. Some contracts can be made cheaper with the verge, and it all comes down to how the contracts are designed and what the practices of the developers are. This is something I wanted to measure. It's the cost of trading tokens on Uniswap. So the x-axis is the number of hops. Like the very leftmost points are just trading token A for token B. And the rightmost point, it's trading token A for token B, for token C, for token D, all the way to like token G or something like that. And so it's scaled basically linearly. And in blue, you have Compound V2. In green, you have Compound V2, Uniswap V2. In green, you have Uniswap V3. And what we see is that Uniswap V2 is a bit less expensive than Uniswap V3 today because there is less logic with the narrowed down position and the capital efficiency. And that will greatly, like this additional storage will greatly be visible in Uniswap V3. So it's likely that Uniswap V3 is still the better choice after the transition to Verkle because it's just way more capital efficient and the gas you pay will be saved elsewhere because of like you will have better prices on your token. But something that interests me a lot is Uniswap V4 because Uniswap V4, unfortunately, I was not able to run it in Verkle. We can go on that later on. But Uniswap V4 doesn't use that much storage, at least not on the token side, because of the singleton design, there is no token transfer for the intermediary token. It's just like the first token and the last token that are being transferred, and the rest is just handled internally by the singleton contract. So I'm curious, I'm sorry I could not get those numbers, but whenever I get them, I'll make sure to share them everywhere I can, like on social media, because I want to see how Uniswap V4 does in Verkle. I'm expecting it to do pretty good. Maybe I'll be proven wrong, but maybe there is a very strong case for Uniswap V4 here. And again, I think that using transient storage and doing the way Uniswap before does it is probably like the kind of good design that we may want to do right now because they are good, but also in the long run because they will be more Verkle friendly. So smart contract design for a Verkle EVM, what you can do now. So it's pretty simple, like you want to avoid storage and you want to pack your storage together. And that's something I did for my last talk that was at HCC, is taking ERC 721, the token, and try to put stuff together. In particular, we discussed the fact that there is a token approval, an operator approval, an owner, and a balance. And the thing is that the owner and the token approval are both mappings that go from unit 256, which is a token ID, to an address in both cases. And rather than have two mapping, let's have a single mapping with a structure. And so when you load this structure, you are likely that it falls in the same extension. In some cases, it will not because of randomness of cache hack, but usually it should. And so these are changes that you can apply today. The reason we don't do it is because on the main contract is because it would break our storage layout, and that has an impact on our upgradable contract. But we could technically do it today. And like when you run them on the test network of Verkle, and again, the slides will be available online, so the links here, you will be able to click on them to look at all the witnesses. But you can see that on the left, it's the traditional ERC 721, and on the right, it's the one that is packed. And you see that you have two S loads that are significantly cheaper. Those were pretty old numbers, so I'm not sure the gas prices would be fully correct here. But the idea that the witness is smaller because of the packing, that remains valid. And so this is measured with today's number. You have ERC 721 from the main repo on the left and the packed version that is just my edit on the right that we don't ship yet. And you see that the prices of running these two versions today on Cancun is basically the same. Like it's marginally different. That's experimental error. But after transition to a Verge node, like you see that the ERC 721 packed really greatly reduces the overcost of like warming up the extension by about a third. Like we move from 3 extensions to 2 extensions somehow. So that's basically what we expected. So there are design decisions that you can make today that may not impact the optimization of your code right now, but that may have consequences in a few months, a few years, if we do this transition to the Verge for having a more stateless Ethereum. So the conclusion is the Verge is not going to break your contract, you're safe. At worst, it will be a bit more expensive, but most systems should be able to work with that seamlessly. But it will affect the cost, and you can make decent decisions today to improve that eventual future. And the decision you have to make are try to avoid storage, and that's a general set of rules, like avoid storage if you can. And if you cannot avoid storage, try to use contiguous storage. So use arrays instead of mapping. If you are writing a compiler, you can do a lot of work here, like in the arrays, or in Solidity and Viper, the lengths of an array are stored at the pre-image of the array, and then the value are stored at the hash of that pre-image. You could decide to put the length at the first slot of like the image, and not store anything at the pre-image. You would just shift your array by 1 and put the length at the same location as the first item. And it's likely that when you access low item in your array, like it's one less extension you have to load. So that may be an optimization. I've discussed that at length in my previous ETHCC talk. So if you are able and you are interested, have a look at it. Again, the link to the slide will be at the end. And yeah, like we do have some Verkle-friendly design choices, like in ERC 7201, and hopefully, like the compiler will take care of all of that at some point. But for now, it's not the case, and it will be breaking the storage pattern. So I'm not sure. I mean, something Solidity has never done before. So yeah, if you are inventing a new language, take that into account. Okay, thank you, and link to the slides. And if you just type share.hadriencroubois.com, then it's indexed, you can get it from here.
Amazing, great job, Adrian. All right, so we're gonna get started with the questions. Remember, you can scan the QR code, you can send your questions. Thank you for the person who just did. You can also vote for the questions so they, get answered first. So thanks for the great presentation. So let's start with the first one. A little off topic, do you also evaluate contract designs that optimize for EOF?
Not yet, but EOF is certainly something that is coming, and likely sooner than Verkle. So we definitely, care a lot about EOF. We want to make sure that it's not going to break our contract. We hope that we are able to ship the same contracts that work with EOF. It's unclear whether we are going to be able to do that or not. Maybe Solidity will have a major update anyway. But like we worry about EOF. I just don't have any final result to give you today.
Great question. Yes, keep sending the questions. Does OpenZeppelin has an array lib that stores the length in the first slot?
No, we don't have that kind of low-level libraries, not yet at least. So far, we've tried to always work with the Solidity layout and not modify it. But other people are doing it, and maybe we'll do that in the future. Why not? That's a good idea. We will have to discuss it.
Yeah. I think that you also mentioned a call to the compiler teams to just like start thinking about all these changes. So if there's anyone here to listen or set to a friend, I think that'll be useful. When do you expect that compilers, very relevant, Solidity and Viper optimize for Verkles?
That's a very good question. I really don't know, and I'm not very optimistic. One particular reason is that Solidity never broke their storage representation, and that would mean breaking something they've never broken since 2015, 2016. So definitely not in version 08. Probably not. I expect Solidity 09 will probably be EOF or something like that. My expectation is that Solidity is moving to a completely different design of the compiler with standard libraries, and the compiler will be smaller. And maybe that's when, like, the standard library, maybe OpenZeppelin, I mean, I'm counting that OpenZeppelin builds such standard library if Solidity ever relies on them, and that will be our job to do this kind of optimization. So yeah.
Great answer. All right, sorry, let me mark that. Okay, let me ask this question. Does it make sense to implement a set of addresses like 721 approvals with an array instead of mapping, maybe for a few in a set or as a cache?
It really depends on the length of the mapping and how you access it. So not as a general rule, no. Maybe in some particular cases, yes. And that's what I want to encourage you to measure and to, like, maybe next year at DevConnect, you give a talk about that.
Great. How does code chunking cost affect dApps?
I'm not sure I understand what code chunking costs, so maybe we can discuss that after outside, and you can give me more details, because I cannot provide an answer right now, sorry.
Yeah, no, that's fair. It seems like 20% more expensive transactions is a big deal, even if it's 10K. Any idea why?
Well, I mean, when you look at small transaction, yes, plus 10K, it's 20%. Yes, it may or may not be a big deal. I mean, it really depends on the gas prices, because like plus 20% if Verkle means that like we have better stateless client and we have a lot of crazy things and we have better L2s and things like that, maybe having a bit more cost on L1 is acceptable. And any idea why? So why it's more expensive? So why is loading and extension so expensive? I did not explain why. The reason loading and expansion is so expensive is because you have to do a person hash of your account address with the first 31 bytes of the asset. And a person hash is complicated to compute, way more complex than a cache. And so the node have to account for that complexity when they execute the transaction. That's why they're going to make you pay a lot for that. That's also why we have extension. We don't want you to pay. I mean, the core devs don't want us to pay this person hash for each slot we access. So they give us 256 bytes slots extensions.
Great answer. I think there's no more questions. So Hadrien, thank you so much. Please give him a round of applause.